grade 10s, as per usual, I will allow for a minute or two to just let everyone who would like to attend join us this morning. I'll see you in 2 minutes' time. Okay, it seems that everyone who would like to join us are joined in and we're ready to start. So just to make clear, we're busy with the grade 10 mathematics webinar. This webinar is pure mathematics and it's not mathematical literacy. If you are a mathematical literacy student, you're welcome to just look at the timetable or keep your eye on our social media on Facebook, where you will see that mathematical literacy will only be presented next week. So for those of you who don't know me, my name is Linky Young and I'm the Chief Education Specialist at Impact for Mathematics and Sciences. So I've been doing the webinars during this lockdown period and I hope that all of you enjoy the sessions and have learned something from here. So before we start, I would like to cover some basics. So if you're struggling to hear me, please make sure that your audio is turned up and that your speaker volume is on high. I just want to highlight that for the guys who can't hear me. You will automatically be muted when you join into the session. I am allowing time for questions where I will unmute you. You can ask your questions and then I will mute you again. This is just to minimize disturbances on the backgrounds. Should you have any questions to ask, you can ask it in the question box on your dashboard. At the end of the session, I usually get time to go through those questions. So if you are not comfortable with asking your questions online, you're welcome to just leave it in the question box over there. So all of you who have joined me previously for sessions, you know that there's a little hand icon that you can use. So you put up your hand to show me that you can hear me or that you have a question. So you can test that out quickly. So put up your hand, use that icon so that I can see that you can hear me properly and that you know where is that little icon over there. I see a few hands going up. I'm still waiting for a lot of hands. Okay, there's a lot of hands going up. Great. I'm going to take down the hands on my side for now, as I am going to allow you later on to make use of that button. Okay, right. You can download this presentation in PDF form in the handout box. You can do that during the whole webinar. Please make sure that you download it over here during the session. If the broadcast is stopped, you won't be able to download that anymore here. It will still be available on the guided learning platform under resources for you to download later. But if you can do it here, then it's less of a schlep. Right, you will also find all of this information in the question box on your dashboard. Remember to send us your questions. We encourage our attendees to ask questions and leave comments. However, should you leave irrelevant or inappropriate comments or questions, you will be dismissed from this session. If I don't get to your question today and you still have an academics question to ask, you're welcome to send an email to academics@impact.co.za. It usually doesn't happen. Usually I get to all the questions in the session, but should something happen, you're welcome to send your questions over there. If I do not get to answering all the questions that was left in the question box during this session, I will send you personal feedback on each of the unanswered questions. If there were unanswered questions and you did not receive feedback from me in this week, you're welcome to send an email to info@impact.co.za. This recording, as well as all the previous recordings of the webinars that we did present, is available on our YouTube channel. So at the end of the session, I will show you that link again. For those of you who don't know yet, you can go onto there and all of the recordings of all the webinars that was presented during this time will be there for you to view. Great. I hope that you are ready, and I am going to start the session now. I just want to take down everything, otherwise we can't carry on. All right. So just a quick recap again of the term 2 topic. So by this time, you should have actually been done with the term 2 topics if there was a June examination that was being written at the scheduled time. But seeing that we don't have any information regarding that moment, the June examination is not starting end of next week as it should have. So I am going to carry on with this, spend a bit of time on questions and do a bit of examination questions as well, so that you are prepared for when the June examination comes, or if it is only in the November examination. So let's just recap on the topics that you should have been doing during this time and in term 2. And the stuff that we didn't cover up to this point with the webinars, I will carry on with that. So when we are done with the term 2 topics, in the sense of webinars, I will carry on with term 3 topics. Right. Trigonometry. So we spent quite a lot of time on trigonometry. If you didn't join into that webinars and you didn't download the notes that was sent with that, please go and have a look at that. And also download the notes for you. So the recordings, as I mentioned, of the webinars is on the Impact YouTube channel, and the notes is available on guided learning under resources. Then we are currently busy with functions. We started 2 weeks ago. In that short week, we started with functions, and we will be carrying on today. Euclidean geometry, where you need to know all of your theorems that you can apply to questions. Right. Like I said, we will be carrying on with functions today. And I'm not going to do a lot of new stuff. 2 weeks ago, we really started off at the base level. What is a function? How to draw a graph of a straight line and a parabola. And today we will do a little bit extra and do an exam question as well. Right. So like I said, functions you can expect in paper 1. Now in our next session, we will be looking at trigonometric functions. So it means trigonometric graphs, and that you can expect actually in your paper 2s as well. But functions in the sense of straight lines and parabolas, you can expect in paper 1. So all the topics that we need to cover in function is the concept of a function. So what is a function? We've done that in our previous webinar. point-by-point plotting of the basic graphs. We've done that in our previous webinar. Investigate the effect of the parameters A and Q, point-by-point plotting of basic trigonometric graphs. Also investigate the effect of the parameters A and Q on those trigonometric graphs. To sketch the graphs, find the equation of given graphs, and interpret graphs. So the first two, as I mentioned, we've done in our previous webinar. So if you missed out on that, please go onto the YouTube channel, go and have a look at those webinars over there. We focused on the straight line and the parabola. And today we will look at the effect of the parameters A and Q on those two functions. So on the straight line and on the parabola. Firstly, we're going to have a look at the straight line. So let's look at the shape of a straight line. So we've drawn it, we've seen it. We know that it needs to have an X and a Y value, so an input and an output value to draw a point. Let me just show that for you. So there I say I need an X value and I need a Y value to be able to draw this point. I need an X value and I need a Y value to draw this point. 2 points. A straight line is not a curve, right? So we talked about shape and all of those definitions in our previous webinar as well, and you will see a lot of that comes into play here now. So you will see we will talk about the y-intercept and so on as well. So if you forgot about all of those terms and what they stand for, I'm also going to refer you to our previous webinar. Okay. The standard form of a straight line is represented by y is equal to ax plus q. So you will see that there is no exponent that you can see there at the x. It's actually a 1. It means that it is a straight line and it is not a curve. You will see what the difference is between the straight line and the parabola right now. So I'm sure that a lot of you have seen this y is equal to mx plus c. So the m represents the same variable as a, and c is the same as q. So this is a bit of an outdated formula, the mx plus c, but it still works. You are allowed to use that as well. You just need to know what applies to the a, applies to the m, and what applies to the q applies to the c. So they have changed that to the a and the q so that it is more universal. You will see that the a and the q can be seen throughout all of our functions. So up until grade 12, you will see that they make use of an a and a q, and later on a p as well. Right. So what does it stand for? My a represents my gradient or my slope. So I want you to think about what that means. My gradient or my slope. It means that how steep my line is. Q represents my y-intercept. If you think back to our definitions that we have done, we said that the y-intercept is the place where the line cuts or intercepts our y-axis. So if I look at this straight line over here, this point that I'm indicating, this is your y-intercept. So if you just look at the formula of a straight line, y is equal to ax plus q, you can already see just by looking at it, at what value will my line cut my y-axis. So when we work with straight lines, you will always see the formula y is equal to ax plus q. So let's look at the effect of my a to a straight line. So I said that a is represented by my gradient or my slope, and it actually indicates how steep this line is traveling. So how steep you're walking up the hill over there. So I chose this formula, y is equal to 3x plus 1. And in this case, I've drawn it for you. So this is how the straight line y is equal to 3x plus 1 looks. So just to recap, how do we draw it? You can either make use of the stuff that I'm going to tell you today, or you can make use of your table method that we have done in our previous webinar, where you can choose x values and then you calculate your y values. So you choose a certain set of input values and you calculate your output values. Right, so if you have gone through that process, you will see that this is the line that you will come across. So I know that we're not looking at the Q at the moment, but I just want to show you how easy it is to actually identify it. So we said that that plus 1 is actually, and it is the y-intercept. Look there. This line cuts my y-axis at that point, plus 1. I said that we're actually looking at our A at the moment. So A is not 3x. A is equal to 3 because it's A times x, right? So there's 3 times x, so my A is 3. As mentioned, it represents my gradient or my slope. And what does it mean? It means it indicates the steepness of the line. And you can actually calculate that. So any pairs, 2 pairs of points on your table or on the graph as shown here, you can actually calculate your gradient. So your gradient can be calculated by the change of your y values over the change in your x values. So this triangle over here just indicates a change. It means the words change. And how do I calculate the change or a difference? By subtracting. So if you look over here, I have a pair. We call that a coordinate pair, where I have an input value with its corresponding output value. I have an input value over here with its corresponding output value. So you can take these 2 pairs of coordinates and you can say the 1y minus the 1y over the corresponding xy, my x value minus the corresponding x value over there. And you will actually get to your gradient. In this case, your 3. So we don't have enough information to just calculate it by now, but this is for you to know that you can actually calculate your gradient. So the gradient can also tell you if the graph is increasing or if the graph is decreasing. So we talked about increasing and decreasing as well in our previous webinar. So just when I look at this line and I start from the left, there is a little hill that I can climb up. So this graph, this function is increasing as my x value is increasing. Okay, so we also read a graph as we read textbooks from our left to our right, and I can see that the value is getting more as I move across this line. So it is definitely increasing. So my A in this case, if I look over here, is positive. So by just looking at my gradient and I see that it is positive, I know that this graph or this function will increase. It has a positive gradient or slope, so it will be increasing. But when I have a negative value like -3 for my gradient, I know that the graph will be decreasing. So the value of the graph will decrease Right, so here I've given a few examples of what happened when my slope is a higher number or a lower number. So I wanted to see that both of these gradients are actually positive. So this is not written nicely. It should be a half x and this is 10x. So my gradient over here is 10 and my gradient over here is a half. So what can I see over here? This pink graph or function over here is represented by 10x plus 1. And the purple line over here is represented by a half x plus 1. Do you see both have a y-intercept of 1? Okay. So all of them are cutting my y-axis over there. So if I look at these graphs, I can see when my gradient is higher, is increasing, the steepness of this graph will increase. So if I need to walk up this pink hill over here, it's more steeper than this one that is a half x plus 1. So the higher my value over here, so the higher my gradient, the steeper my graph will be. So that is the influence of A on it. I think I also showed you some negative gradients over here. Let me just get this again. So we said when I have a negative gradient, I know that my graph will be decreasing. Now I'm walking down a hill. And this happens again. So -1, I'm on this blue line, but if I have a -5, do you see it's again more steeper than the -1? All right. Is everyone still with me? You can quickly put up your hand just to show me that you are following and that you can hear me. Okay, great. Great. So the part of the work said that we need to look at the effect of our gradient, which is A, and Q, the y-intercept. Okay, I'm just going to take down the sign. So we said that if it is positive, if my A is positive, I have an increasing graph. When it's negative, I have a decreasing graph. And the steepness is indicated by the value of that number. So the higher the value, the steeper it will be, either being increasing or decreasing. Right. So now we need to look at Q. And I mentioned already that the Q is my y-intercept. I'm still going to make use of the same graph that we looked at for our gradient. So that was easy to see. +1, we talked about it already. It cuts my y-axis. I've drawn two different graphs over there for you, just to show you the different y-intercepts. So if I look at this, it should be y is actually equal to 2x plus 3. Sorry, there's a typo over there. So y is equal to 2x. So the +3 is my Q value. It means that it needs to cut my y-axis at 3. And there you can see that very. If you look at the blue line, y is equal to -x minus 1. It should have a negative slope, right? Because my gradient is negative. And it needs to cut the y-axis at -1, which is also clearly indicated over there. Okay, I think that was quite easy. The next one that we're going to look at is our parabola. And our standard form when using parabolas is y is equal to ax squared plus q. Right, so as said with a straight line, we only had ax plus q, and with a parabola, we have ax squared plus q. That x squared tells us that it is a parabola, and that I actually have two x-intercepts or two x points that will cut. No, it won't always cut on your x-axis, but you will have two x values when you do calculations over here. All right. So I've drawn this graph for you, and again, as we looked in our previous webinar, you can make use of your table method. So our A indicates how wide this graph is. So if it is a narrow graph or if it is a wide graph. And just to show you that there again, I have my Q, which is +1. So our normal graph will actually be y is equal to x squared. And this blue graph would have gone through the point 0, 0. This +1 said that it moved up 1 unit, and now it cuts my y. I've drawn a few different graphs over here so that we can check what is the influence of this A. And I said that the A actually indicates how wide this graph is. So let's start at the widest one over here. The widest one is actually representing y is equal to a half x squared plus 1. So you'll see all of these graphs will have +1s. So I moved a unit up. Right. So if I have a half x squared, you see it's very wide. The next one is x squared plus 1. So it's 1x squared plus 1. It's a bit narrower. And the narrowest one that is drawn over here will have 5x squared plus 1. So what is the influence of the A over here? The higher the A value, the narrower my graph will be. I'm going to repeat that. The higher my A value, the narrower my graph will be. Now we only looked at positive A values over here, so half, 1, and 5. And we always talk about smiley faces or sad faces. So a positive A will always have a positive person, a smiling person over here. So you will have a smiley face. When it is negative, you'll have that sad face, a negative person. I do have some examples here for you as well. So just to show you, both of them have the absolute value of 2. The one is positive, the one is negative. So if I have a positive 2, I will have a smiley face. If I have a negative 2 for my because their absolute value, absolute is where you do not take the sign into account, are both 2. And it means that the wideness, how wide they are the same. Okay, so just to recap, the higher my A value, the narrower my graph will be. A positive A value will result in a smiley face, and negative A value will result in a sad face over here. So now let's look at our Q value, and I said it is the y-intercept, or in this case, how much this graph moved up. Again, it represents my y-intercept, and I've drawn a few examples here for you. So if you look at this one, x squared minus 2, my Q value now is -2. Remember to take the sign of your Q value into account. It means that it cuts my y x squared plus 1. On my y-axis, it cuts 1, x squared plus 4. It cuts my y-axis at the point 4, the positive 4. Okay, so again, the same as with the straight line, my Q indicates my y-intercept. Right. I want us to look at this example that I've taken out of the 2017 mathematics paper of the DBE. I'm just going to take down the hands for now. I'm just quickly going to check out the question box. I see that there's questions in here. So Christelle asks, Are we going to use functions until grade 12? Yes, we are definitely going to make use of functions up until grade 12. We will do more functions. You will start by doing hyperbolas and exponential graphs. Everything that you need to apply to that will increase as the time goes on, but you are going to do Thomas said that my audio isn't really working. Poor sound. Is there anyone else that struggles with this? Please put up your hand. Let me just see. It seems that there's a lot that is struggling this morning. Please make sure that your audio is turned right up, please. Just want to check on my side. If all the settings on my side is correctly. So please just make sure that you are connected on a nice and stable internet at the moment and that your audio is turned up for me. Okay. So Christelle asked if there's more easier methods to do functions. So the easiest method that we have done is the table method in our previous webinar. So if you missed that, Christelle, please go and have a look at our previous methods that we have done. Webinar. So please just go and have a look at that. So that's the easiest that functions can get. I don't want us to spend time on what is the easiest, but rather on how it is asked in Thomas says the sound is working great. Okay, so I do have, Michael, I do have a very strong Wi-Fi on my side. Yeah, so if something happens, it is out of our hands at this moment. Okay, so Isabella wants to know, how do we draw graphs using X and Y intercepts? And we will get to that in our webinars that is still coming. So you will see, we talk about that. If you go back to our topics of term 2, you will see that that is the last point over there, drawing graphs and interpreting that. So we will definitely, after we looked at our trigonometric functions and how to answer questions regarding that, the influence of your A and Q on trigonometric functions, then we will get to the drawing of the graphs itself. Okay. So Marius asks if you need to watch the math tutorials on my impact. You can, it is help for you and it corresponds with specific questions in your textbook. If you don't want to watch those questions and you're fine with doing a certain question, you're welcome to leave it. If you're struggling with the question, you can go and have a look if there isn't a video for that. I hope I'm referring to the correct video. So the other videos on guided learning is extra for you. So that is where someone is actually explaining the work and doing some examples for you. Okay, right. I am going to carry on with this before I answer any more questions at this stage. Okay, so as I said, I've taken this question out of a question paper that was written, and I want us to work through that. Right, so they say the diagram show the graphs of G, which is ax squared plus q, and just looking at that, I know that it is the parabola. Fx is equal to mx plus c. Remember, I told you about the mx plus c, and that is represented by the straight line. R and S are the x-intercepts of G, And we said that x-intercepts is where my graphs cut the x-axis. So go back to the previous webinar if you missed that. T, the 0.08, and I can see that that is my y-intercept of G. So already I know my y-intercept is indicated by Q, and so I actually already have my Q value over there. Graph F passes through R and T. Okay. So they say I have a straight line, which is represented by F, and I have a parabola, which is represented by G. And if you look at that, you already know that your A value should be negative because I have a sad face over there. Okay. They say that R and S is my x-intercepts, and I can see that that is where my graph, my G, actually cuts my x-axis. The x-intercept over here is 2, 0, and my y-intercept is t08. So my x value is 0, my y value is 8. It means that my q over there will be 8. Okay, and they say that my straight line also goes through the point R and T. Write down the range of G. So the range is actually another word for all of my valid Y values. So you can also go back to our previous webinar where we talked about this definition. So if I look at my graph G, it can be any value from 8 up into negative infinity. So it carries on and on and on in my negative values. So just to show you, it starts over here. And all of these values going down is part of my graph G. So all of those values are valid Y values, and you can use any notation that you know, but I use this one. It is from negative infinity up until the point. So now they say write down the x coordinate of R. So when I look at the point R over there, I also know that it is my x-intercept of graph G. So S and R are both x-intercepts where at those points, you will see that your Y value is 0. If I look here, I know that my Y value over here is 0. So this will have a negative x value because it's on the left-hand side of my origin, and we'll have the y value of 0. So how are we going to calculate that? So I know that my graph is nice in the middle over there, and I know that if it is 2 units to the right, my R should be 2 units to the left. And they only asked for my x coordinate, my x point over there. So it is -2. Okay, so now they want me to calculate the values of A and Q. And A and Q can be seen in the formula of my parabola. So ax squared plus q. And we already said that we have my q value. So t 0, 8. I know that my q value is 8 over there. Okay. Then I take my formula of my parabola, so ax squared plus 8. And I also have the x value of that point t, which is 0. Sorry. Okay, so you could have said, I'm going to substitute this as well. Sorry about that. Okay, but on my parabola, I have another point, which is S, and I have an X value and a Y value over there. And you can substitute in your Y value as 0, X value at 2. Taking my 8 over, it will become -8. 2 to the power 2 is 4. And to get my A alone, I need to divide with 4 on both sides. So I have my Q, which is 8, and I have my A, which is -2, and that is what they asked of me. So In 5.4, they say determine the equation of f. Now they want the straight line. And we said that it is mx plus c, which was given, or I said ax plus q. They used mx plus c over here because I already have an a and a q over here. So if they said calculate the value of a and q in 5.3, you wouldn't have known that at which a or q they are referring to. So that is why they made use of the. So my m is my gradient and my c is my y-intercept. And they said that my straight line actually goes through the point T. T is my y-intercept. So again, I already have that value. So C is equal to 8 or Q is equal to 8. And I know that this point R is -2, 0 because it's on my x-intercept. I know that the value is -2 and the value of the y point coordinate over there is 0. And I'm just going to substitute it in there. So my C or my Q is 8 and my x value is -2. My y value is 0. And calculating my y value as 4. So if I write it, because I want the whole equation, fx is equal to 4x plus 8. So they say use the graphs to determine the values of x for which fx is equal to gx. So that is all the points where the two graphs cut each other, where they are equal to each other. Now this happens at the point R as well as at the point T. And I have that coordinates already. So you can say it happens where x is equal, because I want the x values, where x is equal to -2 and where x is equal to 0. So I want you to note that the use of the or word over here. When you have questions like this in your examinations, you always need to write or and not the word and. If you think about yourself, you can only be at one place at one time. So they want to know where this happens, and you can say at x minus 2 or where x is equal to 0. It cannot be at two places at one time. They say where x times my gx is smaller or equal to 0. I want to use this now. So it's my x value times my y value, smaller or equal to 0. So I want us to think about that. Smaller or equal to 0 when I multiply two values, because it says x times gx. One should be positive and one should be negative, because a positive times a negative is a negative, or one of them should be a 0, because they say smaller or equal to. So smaller than 0 is your negative values and equal to is your 0 value. So that is where my x and my y value is one positive, one negative, or 0. Okay, so that's a lot to think about. And I want us to look at a Cartesian plane over here. A Cartesian plane divides the area around a graph into 4 quarters. So if I look at this one over here, we actually call this the first quadrant when you think about trigonometry. So let's just focus here. At this quadrant over here, I have positive x values and I have positive y values, right? So I have a positive x and a positive y. Positive times a positive is a positive, and that is not what this question is about, okay? If I look at this quadrant over here, that's my second quadrant, I have positive y values with negative x values. Negative times the positive is a negative. So definitely I'm going to work in this quadrant over here. Here I have negative x values, negative y values, negative times a negative is a positive. So I'm not going to work in this one over here. Here again, I have negative y values with positive x values. So here I will have a result of negative values again. So now I just need to tell them what is my x values over here and what is my x values over here. So if I focus on this quadrant over here and I need to speak about my x values where my graphs are, they start at -2 because r is my x-intercept and we said -2 is my x value over here. It can be 0, so it can be included on this axis over here. So my x values go from -2 up until 0 because it's this whole space over here. Okay? Then I need to talk about this quadrant over here, and there's no x values in this quadrant for this space. But it starts at this point S, so from 2 up until infinity, that is what my x values will be in this quadrant. So if I need to write it down, it will look like this. So x is an element from -2 up to 0. So again, look at the second quadrant. R is the point -2, and it goes up to the point where my x value is 0. So that's why we say from -2 up until 0, or from this point S, which is 2 up until infinity. Note the word or. Okay, now they say the graph H is obtained when H is reflected along the x is equal to 0 line. So it's over here. I need to reflect it to the other side. The only thing that will happen is my x values that will change sign. Okay. So it was, remember we said that A is a -2. It will now be a +2 minus 8. So when my y value is 0, so over here I'm folding it on my x-axis. So what will happen is it will flip over to this side. Okay. So we have done a lot of work now, and I want you to go back and have a look at everything that we talked about over there. So I've given you some extra links that you can go and have a look at, and you will see it's the same as last week. There's a lot of extra information over there. I've also included the YouTube links to our guided learning videos, as well as the YouTube link where the recordings of the webinars are. That's the red link. So I'm going to take down all the hands. And if you have a question now, please put up your hand. Okay, Nicholas.
Hello, ma'am.
Nicholas. Hi.
Ma'am, I just wanted to know, so when you do a straight line graph, where the line intersects your y and x axis, uh, I've noticed it forms a triangle that's 90-degree angle.
Yes.
Can that be important in an exam?
Not with functions itself. Later on when we do it, analytical geometry, yes. What you can use that triangle for is actually to calculate your gradient. Because we said the change in your y over the change in your x is equal to your gradient. So you can actually take your y-intercept over your x-intercept, and you can also calculate your gradient like that.
Okay. Thank you, ma'am.
Okay, pleasure. Right. Anyone else with questions that I can help out with? I'm just scrolling through the list quickly to make sure that I don't miss anyone over there. Right, Catherine. Catherine? Catherine, do you have a question? You're self-muted, so if you want to ask, you need to unmute yourself. She took down her hand. Okay, let me just quickly scroll through. It's indicated that somewhere there's a hand up. I'm just scrolling through that quickly now. There we go. Muluhanta. You are self-muted, so if you have a question, you need to unmute yourself. There we go. Do you have a question? Seems that there's a problem on that side. I am going to scroll down even more just to make sure that I didn't miss anyone. Michael Brink? Michael, do you have a question? No.
No.
Hand is going down. All right. Okay, I'm just quickly going to the question box. See what I can answer over there. Karabo asked that after the webinar, if you need to do your textbook activities. Yes, it is up to you. This webinar is just for extra information and just to help you through the work should you need some extra help, but you still need to work on your own, guys. This is just something extra on our side. Jeanette says that she can't hear me, but she left. Lebohang actually asked if we will be doing more functions. Yes, we will carry on with functions for the next 2 webinars as well. Okay, and Agatha said that she has written her exam, probably her test because the examinations is not available. Okay, so Mulahanta asked for question 5.5.2. Jeanette, please put up your hand there, then I will unmute you for your question, all right? Mulahantu, I'm going back to 5.2.2 to just have a look. Okay, so the question asks where an x times gx, so gx is actually your y value. If you look at y is equal to ax squared plus q. So where my x times my y value is smaller or equal to 0. So when I'm this smaller or equal to 0, smaller than 0 is negative or equal to. So 0 and less than 0. So all of the negative values up to the point 0. So where I have an x value multiplying with my y value, where it will yield a negative or a 0 answer. So for me to get a negative answer, and because they are multiplying, I need to have a positive times a negative value to give me a negative value, because negative times negative is positive and positive times positive is positive. Okay, so I said we need to look at the 4 spaces around the graph. Over here, I have positive y values and positive x values, correct? 1, 2, 3, 4, 5, and this side as well. So positive times a positive, because we talked about x and y values, won't give me a negative answer over here. Here I have positive y and negative x. Positive times a negative will give me a negative answer. So we need to talk about the x values over here, because the question asks the x values for which this will be true. So the x values in this space over here is this line. And I know that it is from -2, because R is the point -2, 0. So -2 all the way to my 0 over here. So this is where my x values are defined. So from -2 up to 0, At this point, I have negative x and negative y. Negative times a negative is a positive, so we're not going to talk about these values. Here I have positive x, negative y. Positive times a negative is a negative. So again, I need to talk about where these graphs are defined over here. X is the point 2, 0. So my x values that is defined in this space is from 2 up until infinity, because this graph goes on and on and on. Therefore, it is 2 up until infinity. So this is where this expression over here comes from, where we defined the second and the fourth quadrant over here. Okay. Let me see. There we go. Jeanette.
Morning, ma'am.
Good morning.
I just wanted to ask, the two discs we were given at the beginning of this year that come with our math study guide, they've stopped working, so you can only hear the lady speak audio, like you can't, there's like no visual explanation. So I went on to Impact Guided Learning, and they also have like the source videos there, but yet again you can't like visually see what she's explaining.
Okay.
You can only hear her.
Okay, I have a solution for you.
Okay.
We know that it happens with some of the media readers that you get. So the one that always works is VLC Media Player. So VLC Media Player, you can download that for free from the internet. Play your videos
Okay.
through the media player. You will have video and audio.
Okay. Thank you, ma'am.
Okay, pleasure. Okay, I'm just scrolling down to make sure that I've answered all the questions over here. Seems that everyone is happy at the moment. This one, Isabella.
Good morning, ma'am. How are you?
Good morning. Good, and you?
Very well, thank you. How do you find the turning point on a parabola? Do you have to use the y-intercept or the x-intercept?
So there is a specific formula that we need to use to actually find the turning point. And it is a two-part formula. So your x value of your turning point is given by 2a over b, if I'm not mistaken, but that is when you have some bigger parabolas to work with. I will have a look at that. I don't think that you do turning points at this stage. But I will work it in our last webinar regarding functions, because then I'm going to do some extra examination questions, drawing of it, and interpreting of graphs.
Okay, thank you very much, ma'am. Enjoy your day.
Pleasure. You too. Bye. Okay, I think that we are also running out of time. I've answered Jeanette's question. I don't see other hands. I quickly want to look at this. There's nothing in the question box that we didn't answer. Right. Great teams. Thank you so much for joining me this morning. I hope that you learned a lot and that you found it interesting. We looked at all the questions, we've answered everything. If you are not an Impact learner and you want to find out a bit more, you're welcome to contact us and send your questions through to them. They will be able to assist. Again, thank you to each and every one of you who joined me this morning. I hope to see you in 2 weeks' time again. Bye-bye.